and consumptions, water needs and consumptions. In Indonesia, the minimum daily requirements of a person is about or around 200 liter domestic use, while an equal of large amounts will be needed for other purposes. It is estimated in Bandung about 200,000 cubic meter per day is met from groundwater resource. So we will see groundwater explorations and evaluations. We need geographic information system to map and to mapping the parameter and for the analysis. Evaluation of groundwater supply potential is needed to evaluate. We can use remote sensing also and image interpretations to know the land use and land cover that can interfere the groundwater. So we need the alignment analysis of the aquifer. Geologic and structural mapping is also needed to know the distributions of the potential groundwater. Hydrogeologic and recharge investigations is also needed. And for environments, water supply contaminants, threats, mapping, and evaluations. So in these discussions, we will discuss the geophysical investigations. So I will show you different methods and techniques of groundwater explorations. The first, we can explore the groundwater from the aerial. We can use photogeologic landsets, infrared, or aeromagnetic, and so on. And many methods can be used at the surface of the Earth. We need the geological methods, geomorphological methods, hydrogeological methods. Normally, we study this science in geology. And geophysical methods. Many geophysical methods can be measured at the surface of the Earth. For example, electrical, electromagnetic, magnetic, gravity, geochemical also. We can do that. For the subsurface, we need well normally. Geological, hydrogeological, tracer technique, geophysical logging. The data is read it in the well, and the end esoteric is water defining, astrological, biophysical. I think the type of and technique, this technique depend on feeling. I think, yeah, more feeling than mathematics. Next, we see geologic and structural mapping. Yeah. Structural mapping is the identification and characterization of structural expression. Structure include faults, synclines, and anticlines, and linements. The geological formations have different hydrogeological behavior. Normally, they are classified in three main categories. The permeable rock, impermeable rock, and semi-permeable. We normally three types of the permeability. Structure can indicate potential locations of aquifer by characterizing the underlying subsurface geometry using geophysical model and geology data. The assessment of the obtained geological information regarding the type of the soil or rock formation, the stratigraphic position, the geometry formation can be used for preliminary aquifers classifications. So the information of geology is important to design the geophysical explorations. So next, I saw the groundwater analysis using many geophysical data. Geophysical explorations is two types. One's non-invasive ways to map the subsurface, and the second is the subsurface investigations. We can use two types of geophysical exploration. For the surface geophysical methods, we have electric resistivity methods, seismic refraction methods, seismic reflection methods, gravimetric methods, magnetic methods. All of the methods, we can say the potential methods, electromagnetic methods, yeah, ground penetrating radar. Yeah. The two ends methods is used to magnetic field and electric field or electromagnetic. Second, groundwater analysis in the subsurface explorations. We have to drill the subsurface, yeah, and we can get the geologic logging, drilling time logging, water level measurement, and so on. And for geophysical logging or borehole geophysics, we will have resistivity logging, spontaneous potential logging atau SP logging, radiation logging, temperature logging, caliper logging, fluids conductivity logging, fluids velocity logging. And from the well, we can do the tracer tests, yeah, to know the tracer of the contaminants. So next, we will see the electric resistivity methods, one of the geophysical methods, yeah, for the surface measurements. We know electrical resistivity is the resistance of a volume of material of the rocks to the flow of electrical currents. Current is introduced into the ground through a pair of current electrodes. Yeah. Two pair current electrode, one pair current electrode and one pair potential electrodes. Now this is the electric electrodes. This one is electric current electrodes, yeah, and in the middle we have the potential electrodes. So the currents, electric currents, will flow into the rock or ground, and we can measure the potential, and we know the currents in ampere, so we can calculate the resistivity, apparent resistivity of the rocks of subsurface. Yeah. So we have discussed apparent resistivity is then calculated like this. Rho A is the apparent resistivity equal to PA potential divided by electric currents. This is Werner arrangement of electric electrodes, current electrode and potential electrodes. This one current electrodes, and in the middle is potential electrodes. And this one's submersive configurations. Yeah. Submersive configurations normally is used to know the vertical structure or sounding survey, and Werner arrangements for lateral informations or lateral variations of resistivity of the rocks. So I told that's the potential difference, and then we can get the apparent resistivity. Yeah. And also apparent resistivity can relate it to unspecified depth. Yeah. Vertical electrical sounding. Yeah. If the electrodes spacing change, for example, the depth penetrating of the current will be more depth. Yeah. So it is possible to obtain field curve of apparent resistivity versus depth. Yeah. For a single homogeneous isotropic layer or infinite thickness, resistivity curve will be straight lines. So from the homogeneous isotropic rock, we will have the true resistivity. Apparent resistivity we have for the anisotropic or stratified rock below the surface. This is apparent resistivity in ohm meter plotted to electrode spacing, electrode distance. And for profiling or lateral traversing, it means we will have the lateral variations of resistivity of the rocks. Electrode separation is kept constant for 2 to 3 value. For example, 10 meter, 15 meter, or 20 meter. And the center of the electrode spacing is moved from one station to another to have the same constant electrode separations. Normally we use Wenner configurations. So we can detect the subsurface change in horizontal directions or lateral variations. The curve, for example, presents the lateral variations of the Werner apparent resistivity. Yeah. Now, Werner method is most convenient because the distance between currents electrodes and potential electrodes is the same. So we can get horizontal and vertical measurements from electrical methods. And next, we can discuss about seismic refraction methods. Based on the measurements of the travel time of seismic wave or refracted, yeah, we call that refracted wave at the interface between subsurface layer of the different velocity. Seismic energy is provided by a source. We can use MR, white drop, or small explosive charge located on the surface of the Earth. This is the survey of seismic refractions in the fields. Here we can see the geophones, and resource from the center, the center of the array. So the seismic wave of the refraction wave travel through the subsurface at a velocity depends on the density and elastic constants of the rocks or soil. In the figure, we can see the travel of the refraction wave or seismic wave. We can see here, this is a reflected wave, but the wave that travel along the boundary of the sediments, we call the refracted seismic wave. Now, at the surface, we have many geophones. Here we can see, for example, 24 geophones. So the refractions data we can process. that can be processed by software normally. So so due to the compressional stress along the interface between the sediments, a portion of the wave fronts returns to the surface, and we capture with the geophones. Now this is a geophones in the figure. Now from the data we can calculate the velocity V0, V1, and V2 for first sediments, and the second layer V1s, and the third and the deepest ones V2. Yeah. Now this is the formula to calculate the depth of the boundary between the first layer and second layer, and the second layer and the third layer. This is the curve to calculate the V0, V1, and V2, velocity of the layer, first layer, second layer, and third layer. Now, seismic reflections methods are effective information with definite boundaries between strata, and where density increase or velocity increase with each successive lower layer. Now this the figure. Now next is the geophysical logging. Borehole, we can say borehole geophysics. Borehole geophysics or geophysical logging is the methods to measure the physical properties from the rock in the well. Borehole geophysical logging is procedure to collect and transmit specific informations about the geologic formations penetrated by a well by raising and lowering a set of probes or zones that contains watertight instrument in the well. So we can collect the data, many data, for example, resistivity, for example, a self potential, density, logging. We can get that data. So we can apply the geophysical logging to groundwater hydrology explorations. That can be compared to petroleum explorations. But for the petroleum exploration, the well is more deep. The primary reasons for this is cost. Normally, the borehole logging is more expensive. Most water wells are shallow, small diameter hole for domestic water supply, logging costs would be relatively large, sometimes unnecessary. Yeah. If the aquifer near the surface, normally we don't need the logging, logging borehole geophysics. But for deeper or more expensive, deeper, more expensive well, such as municipal irrigation or injection purposes, logging can be economically justified to improve well construction and performance. Now, interpretation of many geophysical logs is more of an art than a science, I think. Normally, we can see the geophysical logs data directly from the graphic. Yeah. Now, this, for example, we have electric log. Yeah. Yeah, we have resistivity log or apparent resistivity. We have gamma ray log. The right one, the left one is SP log, or electric log. Yeah. Now this geophysical log data is related to the certain rock types of rock. Now, so we can see the type of the rock, the lithology. We have sands, we have clay, we have clayey sands, and so on. Yeah. And also in the rocks, we have the porosity, and we get the water in it. And next, SP, spontaneous potential logging. These methods use the difference value in the voltage of electrodes at the land surface and the electrodes in the well or borehole. Potential are produced by electrochemical formed by the electric conductivity difference of drilling mass and groundwater, where boundary of permeable zones intersect a borehole. So the electric conductivity difference is difference between the drilling mats and the groundwater. Yeah. Now, deflection or variation of the SP curve occur due to development of liquid junctions potential. For example, potential difference across the junction from mass filtrates to formations water. Yeah. The potential for shell, the potential value for shell normally varies very little with depth. SP is measured relative to the baselines, zero, called the shell lines. Now, if water in permeable beds or sediments is more saline than drilling mass, SP value is generally more or greater in the permeable beds than in the adjacent clay, or vice versa. So these methods can be used to determine water quality. Yeah. Mineral content, for example, in the water can be detected by the SP methods. So SP can detect the boundary impermeable beds, the boundary of impermeable bed. For example, clay, shell, and bedrock. Yeah. Left-hand boundary indicates sand and other permeable layer. And also radiation logging that measure the natural radioactivity of the rocks. Second, detect the radiation reflected from or induced in the formation from an artificial source. Also can be done. Yeah. We will have natural gamma logging, gamma logging, and neutron logging. Yeah. Now the next, we will have the analysis of groundwater using gravity data in Bandung Basin. In Bandung Basin, West Java, Indonesia. We know all geophysical methods normally, it is not easy to use to get to study the groundwater, because in the urban area, many structure can be can make difficulties for the survey, but the gravity methods is the easiest to do for the groundwater analysis in urban area or city, both for exploration and for monitoring the groundwater. Well, the gravity is the simple ones methods to apply to the groundwater study. This is the water transfer between aquifer. We have the aquifer, upper aquifer, middle aquifer, and lower aquifer. We can see in 1960, water flow in the upper aquifer up directions, and about water debits around 13,430 cubic meter per day. And for the lower aquifer, the flow directions is down, and the water debits is about 42,639 cubic meter per day. Now, but in 2008, the upper aquifer, the water flow is down. Before we have up direction and here down direction, and water debits for the upper aquifer in 2008 is more greater, 186,208. Before only 13,000. And 2008, become 186,000. And for the lower aquifer, the water flow up directions, and water debits is about 31 cubic meter per day. Now, this is the area of Bandung Basin, and also we can see the geological map of the Bandung Basins. Now, our area is the box, the red box. This is the topography maps around Bandung, around Bandung Basins. This the city of the Bandung, around the Bandung district. We have the gravity measurements. Here we see the points of measurements with the yellow points here, distributed all around the Bandung Basins. Now, the time-lapse gravity measurements points is about randomly distributed. And also, we have the satellite data, radar satellite data. That's will be processed using InSAR technique, and the result is the land subsidence of the Bandung. So InSAR is the interferometry SAR. This is a technique that studies phase difference between two SAR image in the same area taken from different times. Now there are satellites. There are several satellites that can be used for processing InSAR, including ERS, ALOS, PULSAR, and VISAT, and Sentinel. In this study, we use Sentinel-1 satellites. Imagery was launched by the European Space Agency, ESA. Now, so the data of the two Sentinel were got, namely May 4, 2015 and November 11th, 2016, or about around one year, more than 1 year difference. The interval between May 2015 and November 2016. So we hope the difference of this map, we can get the topography or the difference of elevations, so we can get the subsidence of the surface. Now, this is the two data of Sentinel. The left one is 2015 data, and the right one is 2016 data. So the two data will be processed and calculate the the difference of the two maps. Yeah. Now, so one of the images will be chosen as the master, and the other will be the slave. So the 2016 will be the slave. So the difference with between slave and master, between two data. Now we need the reference points. Yeah. The reference points is the coordinates UTM. This ones, yeah, UTM X 790151 and Y 923918 coordinates that are located in Lembang region. Is located in Lembang region. This is the monitoring well points in the city, in the study area of Bandung Basins. Yeah. The location of the well is displayed with the blue dots. Yeah. Blue dots. And also we can see the several formations. Yeah. Formation Kosambi, Ciberem, Cikapundung, sediment tertiary, and so on. Now, this one is the results of the InSAR, InSAR technique. So we can see the this is the value of subsidence. Yeah, subsidence. The blue one is 0 and the red one about 30. This is around. So the black one, the black color, we don't have the data, because of the surface. Yeah. For example, the vegetable is not good for the radar reflections. So we need the good reflection to have the distance from the satellites or elevations of the surface. This is the precipitations of the Bandung city in the 2015 and the 2016. The blue one is the 2016, the blue one, the blue one. So we have the survey in May 2015, and we have survey in 2016. The curve is the reds, the red ones, the red one. September, or this is the begins of the wet seasons. So normally the infiltration in the Bandung area is very small. Infiltrations of the rainwater, precipitations is so the runoff is great. Now, this is the measurements of gravity in the 2015, the left one, and the right one is the 2016. The blue one is low value. The red one is high value, high value. Now, but this is the gravity measurement points and gravity time lapse. Bandung Basins. Bandung Basin. The blue one is high and the red one is negative. The red one is negative. the value control of gravity time lapse in the Bandung Basin, periods between 2015 and 2016. Nah, negative anomaly is red and positive anomaly is blue. So the red ones, negative anomaly, related to decrease of groundwater table. Level of groundwater become lower. So the time depth gravity become negative. Now this is the groundwater table in the several well in Bandung, monitoring well in Bandung. Now this is the groundwater table. This time-lapse gravity, and this one the difference in water table. Now this is the model of time-lapse gravity. Time-lapse gravity. So we can see here the blue one. This and the blue one recharge or positive, become positive anomaly because this area, in this area, the water table become higher. And these ones, red ones, the water table become lower. So this is the position in profile west east. This one, and the middle is red. The profile southwest to northeast here, and the last one is the north and south profile. This is near Cimahi, the red ones. Now we can have the roughly conclusions through the radar satellite data Sentinel-1 image. Bandung Basin land subsidence map is obtained from the periods of 2015 to 2016. The value of land subsidence occur is about 4 to 28 centimeters per year. The biggest decrease occur in Cimahi. We know there is industrial area, and also Rancaikek and Dayakolot. We have the bigger declines of anomaly, surface. The value gravity change between 2015 to 2016 is around minus 120 microgal to 80 microgal. Now, gravity anomaly were detected in the city Bandung and surrounding. Yeah. The greatest value is Cimahi area, Dayakolot, Antapani, and Rancaikek. Yeah. Now, the change of the groundwater table, yeah, is around minus 5 to minus 5.4 to plus 4.6 meter. Yeah. So the range about 10 meter, yeah, maximum and minimum. Yeah. I think we can discuss the the topic if you want to ask the questions or you want to propose the idea, etc. Thank you very much, Pak Wahyudi.
Okay, thank you very much for your interesting presentation, Pak Darharta. Now is question and answers session. Please ask your question and write it in the chat box, or you can raise your hand directly. So yeah, so there is a question, Pak Darata. Could you see the question in the chat box from Armita Lestari?
Chat box, okay. Chatting. Interesting topic. How we can measure the volume of the groundwater using geophysical methods. Okay. We can make the model of the groundwater table difference between two times. Yeah. So we from the model we can get the interval up and down of the maximum and minimum of the difference of the water table. And also we can have from the model the area of the time lapse of the water table. So we can estimate between the difference of the interval between highest water table and the lowest water table, between the difference between water table between 2015 and 2016. So we have tides and area. Yeah. So we can and also we have to know the porosity. Yeah. If we don't have the porosity data, we can estimate, we can guess and assumptions, yeah, about the porosity. So I think that we can calculate roughly the volume from the model of geophysics.
Okay, is there any question? Another question or other questions from audience?
Thank you, Pak Darharta, for the answer. I have another question. What do you think about the geoelectric method is very often used for groundwater? Will there be another method which also be better to use for groundwater? Thank you.
Yes, yeah. We can use the electrical methods, depend on the area. If the area, for example, in Bandung city, I think it is difficult to use the electrical methods. Yeah, But if we study, we learn the groundwater in the Lembang area, for example, or in the south of Bandung Basin, we have the mountain area, so we can use the electrical method. So electrical methods depend the land use or land cover. If you know land use, how what is at the surface. For example, land use for roads, for example, land use for industrial area, or another. So, for example, also for vegetations, plantations, agriculture, for example, it is different. So in the inner part of the city, in the we have many structure that cover the surface of the earth. So difficult. It is not possible, I think. If we use the electrical methods, we have to calculate the corrections, correction of the many pipes, for example, a radio wave, for example. This is difficulties for the electric methods. It is good for detecting the resistivity or the water contents in the ground, in the rock. Resistivity is very good. So I think if it is possible, for example, we can get the logging in the city, but it is not easy. It is not easy. Thank you.
Okay, is there any other questions? Please raise your
Thank you,
hand and
Father.
directly ask.
You are welcome.
Okay, Pak Darharta, I have a question.
Yeah.
So what geophysical methods should we use to know the sediment underwater? For example, under river. So what geophysical methods is best to
yes. It is not easy to get the the structure under the water. In the river, So I think we can use radar, for example. But we have also okay. I think so. We need the correction. I think many noise can be arrived in the data measurements. I think.
Okay, thank you, Pak Darharta. Is there any questions from audience? So we are waiting for other questions.
It is difficult to understand, I think, for the students.
Or the students.
All the students
knows
because
they knows every. Okay, yeah. Pak Darharta.
Yes.
Okay. Yeah, so if you want to know about the subsurface structure,
yes.
For example, what is a slope, in the slope. So what geophysical method is used, and do we need to use also borehole logging to know better estimate?
Yeah, it is. the best one is the borehole geophysics, I think. Yeah. But yes, but we have to calculate the price for that. Yeah.
Mhm.
I think it is good, yeah, to get the data from the borehole methods. Yeah. In the rough area, slope, I think hill slope, I think, Pak
Yeah,
Wahyudi.
yeah, yeah.
Yeah, slopes. Yeah. So
Okay.
we can use also geoelectric, I think, but we choose the profile position, yeah, and normally we can use gravity. Yeah, can use gravity is easy to down. So gravity methods is not difficult. Yeah, it's not difficult to measure the data. I think so. Gravity magnetic, yeah, also we can use these methods.
Okay, thank you. And maybe there are questions from the audience. Dr. Indra, do you have questions? Oh yeah, so you can see in the chat box, Pak Darata. So a question
Box.
from Dr. Indra.
Dari Pak Indra, thank you for the interesting first. I want to ask a question. Can we detect seawater, saltwater intrusion in the subsurface using the geophysical? Yes, we can. Yeah, yes, we can. We can do that, but we have to do carefully. Yeah. We have to get the high accuracy and high precision. Yeah. So also I think so. We can get Pak Indra, we can get this data. We choose the goods, the precise instruments, yeah, accuracy, yeah. So we have to get the instruments calibrated, yeah. Yeah, instrument calibrated. So the measurement is accurate, yeah, accurate and precise. We can get that, Pak Indra.
Okay, maybe this is my last questions for you, Pak Darata.
Yeah.
So, for example, on the beach.
On the beach, yeah, coast,
So,
yeah.
yeah, and we conduct gravity measurement.
Yes.
Yeah, and due to gravity attraction from seawater, yeah, from what is seawater. So it's
Measurement in seawater,
in a
offshore,
measurement on the beach,
on the beach. Okay,
on the
okay,
beach,
okay.
yeah.
Yes,
So
yes.
how close can we measure in the
Yeah,
beach?
yeah. We know along the coast, along the beach, we have the wave of the sea surface. So there is noise, yeah, for the instruments, gravity instruments. So we have to measure, take a distance from. I think I don't know. I think 50 meter. I think from the coast. I think, but
Is there any formula for that?
no.
Yeah,
It depends. It depends, Pak Wahyudi.
Okay.
The distance it depends to our objective. For example, if we need the data little noise, yeah, we have to avoid the cost, the wave noise, yeah, from the sea. But we need the structure of the beach. We need the subsurface structure. How about the structure? So we need the data. So I think, for example, we choose the time the wave become calm, become yeah. I don't know, in the morning or in the afternoon the wave is no, the wave, yes. The wave become little, become, I think, yeah, I think we know along the beach, along the coast, we have the wind direction, wind, sea wind, sea direction. I forget. Terrestrial wind and sea wind. So if we have the times in between, it is okay, I think. Yeah. The small one of the wave. Yeah.
Okay, thank you, Pak Dararta. Yeah, so last chance for audience. Is there any other questions from you, from the audience? Okay, I think there is no question more, Pak Dararta. So
thank you very much.
Thank you very much for your lecture, and
excuse
thank
me, I
you
can
very
speak
much
fluently.
also. Yeah, for all
There
attendance.
is a
And
question
now,
Yes.
photo session.
Amita,
question from
yes.
Mas Irfan Prasetyo in the chat
Irfan.
box.
Oh yeah, okay.
Chatting.
Yeah, there is one question.
Mas Irfan Prasetyo asks how to distinguish whether the resistivity method can be used to detect wastewater infiltration, environmental pollutions, wastewater, to detect the wastewater. Yeah, how can distinguish the wastewater and the pure water? Not pure water. I think it's the fresh water. Yeah, fresh water. Now, so normally there are different resistivity between fresh water and wastewater. Normally. So, but the difference is not so big to detect by the electric methods. So we need the geological lithology, more precisely, I think. Yeah. So we can now the wastewater and the fresh water, the difference of wastewater and wastewater. Yeah. So I think if we use the borehole logging, boreholing, it can get the more accurate, calculations, more accurate calculations. So if we use the electrical methods only, without logging, it is more difficult to get the difference between wastewater and fresh water. So So we don't know is the difference of resistivity come from lithology or come from different water, fresh water and waste water. This is the problem. It's a problem. So if we know the lithology more precise, we can get the difference. I think, yeah, we can get the difference between wastewater and freshwater. Yeah. Using resistivity, using resistivity methods. Yeah. Thank you for the questions.
Okay, is there any questions? Any other
Mas
questions?
Prasetyo.
Yeah, from Ramadhani, do you have a questions? Okay, I think there is no more questions, Pak Darata.
Yes.
Yeah, so thank you very much for your
Welcome. Thank you very much for all
Yes.
participants.
Okay, and thank you also to all attendants. And now
Attendance.
a photo session, so don't leave
Okay.
this room now, Pak Darata. So
Yes.
photo session first. Harmita, please.
Yep, Pak. So everyone, please turn on your camera. We are going to the photo session. The first page, 1, 2, 3. The next page, 1, 2, 3. The last one, 1, 2, 3. Okay, thank you everyone. Thank you, Pak Darharto, for very interesting topic today.
Okay, thank you, Miss Harmita. Thank you, Pak Darharta. Okay, and thank you also for all attendance. We meet again this afternoon, this evening at 7 o'clock, and with the lecture from Dr. Dedi Apriyadi about introduction to finite element method for slope stability analysis. So don't miss this chance to see this interesting lecture. Thank you very much again, and the session is closed.
Thank you.
Thank you.
Thank you.
So I end this meeting.